Hi, welcome to Parametric House. In this Grasshopper example file, I'm going to explain how you can produce this final results using point attractors. So if I just turn off everything and go back to the first cluster, what you're going to get is a simple surface by defining a polyline. So as you can see here, we have to make a polyline based on the height and the widths we want to make our project. So I'm going to just draw a line. For example, I'm going to select this point, use the control key, bring it up, and use the shift key to make an ortho and make this polyline. We can give that to the first input. If you open the example file, there are going to be some clusters. Each of these clusters is a step I have taken to make the final results. You can double click it, open, and check out some additional info I have put in the cluster so you can understand it better. Okay, let's go back here. What you can expect from the first part is a simple fillet extrusion. So as you can see here, this is going to be the fillet of the corner we have produced here. So you can just add more fillet to that. Then also there is a length, which is going to be a simple extrusion in the normal direction of this polyline. So for example, if I rotate this polyline, as you can see here, it's going to automatically find the normal direction in this cluster and extrude it in the normal direction. Okay, that is the first step. After producing the surface, let me just turn it on. You can see that this is the vector display I have put here, so you can understand that it's a normal direction. Anyway, this is just for visualization, so you can also get the visualization output here and the normal vector. The next part is the point attractor. So if I go to here and turn this on, this is the point attractor and this is the deformed surface we're going to get. Let's just turn on the render so you can see the surface. This is going to be the base surface and it's going to be used for the sections. As you can see here, if I just move this around, let's just turn off the next cluster so it's going to be faster. As you can see here, this is going to be the location of the point attractor, and I've just added 2. You can add more to the attractors. The resolution is actually the resolution of the surface. If you decrease it, you can see that the surface has less points to produce, so the surface is not really that accurate. But if you want more resolutions, it's going to give you more details on the surface, so it's a better way of adding the resolution. There is a minimum and maximum displacement. So the minimum is the minimum deformation based on the point attractor, and the maximum, you can also decrease that and increase the minimum, so the point attractors are going to deform the final results. Also, if you open the cluster, you can zoom in the graph mapper section, add some graph mappers. For example, this is like a sine graph mapper combined with Bezier graph mapper, which you can control that here. And you can turn it off by just going to one of the graphs and say I want none for the distribution. And for example, if I want to, I can say I want a conic distribution, I want a sine summation, play around with those, and then you can combine it even with a linear line. You can see that it's going to affect the final results. Then you can just save or just check out the complete example file if you want to learn more. Okay, after producing the surface, we're going to go to the next cluster. I'm going to disable this one and turn this one on so you can see that, and just turn this off. The next one is the curves. So if I just connect a curve to this output, you can see those curves. It's based on the contour. So we have the surface here. We've used the contour length, which is going to be the length we have defined at the first part, and also the polyline profile and the count we want. So that is going to define how many intersections or contour we need. That is going to be the next part of the algorithm. And after producing that, we can just go here and let me enable this one and turn this off. This is going to be the base extrusion. And I've also added a visualization if you want to give some thickness to the top or the bottom. Okay. Let me turn on the previews here so you can see the results, and turn this off and turn this on. Okay. And just for visualization, it's not really that important. In the human plugin UI, you can the human plugin custom preview material, you can go to the diffuse bitmap and select one file. For example, if I select this, I've put 2 materials for that. You can select the wood for the first part, and the second one is going to be a concrete viewport. Let's just turn off the previous previews and turn this on. And I'm going to also give us black. And now I can see that even better. So for example, if I change the thickness, this is the place we can change or increase the thickness for the parts. Again, we have the polyline inputs. The visualization thickness is just a number. So for example, if I add this up, the extrusion of the walls just for visualization is going to be increased. If you want to use the complete example file, you can just open it and check out each part separately and use it in your project. So actually this example file is going to help you to understand how to use point attractors, produce the deformation, and get the final results. If you have any questions, just ask below this example file, and thanks for watching. See you next time. Bye.